All right, let's work on variations, group 2. So on this one, we have Hooke's law states that the net force acting on a spring, so the story is about force, and that's directly proportional to the amount by which it's stretched. Okay, and we've got pounds for force and inches for the length of the stretch. So let's give ourselves some variables. We've got force, and that's in pounds. And I'm just going to say length of the stretch, and that is in inches. We're directly proportional, so it would be set up like y equals k times x, but our story is about F and L. So we've got force is k times L. Now in step 2, we need to figure out, or step 3, what k is worth. So we can do that. We will use this example where we have a force of 15 pounds and it's stretched 3 inches. So 15 pounds is equal to k times a stretch of 3 inches. So I can divide both sides by 3. And my units on this would be pounds per inch. And 15 divided by 3 is 5. Okay, so k is worth 5. But our units there are pounds per inch. And the reason I'm making a big deal of that is because now we need to figure out what force for 10 centimeters. So I can't plug this into my formula is 5 times length because the length needs to be in inches. Okay, so in step 4, before I start, let's do our conversion. Got to convert first. Okay, so I need 10 centimeters, but instead of centimeters, what I want is inches. Okay, so I'm going to use the fact that 1 inch is 2.54 centimeters. Okay, my centimeters cancel. So I'm going to take 10 divided by 2.54, and that gives me 3.94 inches. And now I can plug that right in for length. So I've got F is equal to 5 times 3.94. And that is 17 or 19.7 pounds. And we needed a complete sentence. So the force is 19.7 pounds. Good. All right, let's do this next one. We've got the musical pitch varies inversely. So the story is about pitch, which is in vibrations per second, and it's varying inversely. So in my head, I'm thinking about that setup that went y equals k divided by x. Okay, but it's not about y's and x's. Instead, it's about pitch and wavelength. And wavelength is in feet. Okay, so let's give ourselves some variable pitch. And that is in vibrations per second. And we've got wavelength. And that is in feet. So our equation is not going to be y equals k divided by x. Instead, it's going to be p is equal to k divided by wavelength. Okay, so there's our step 1. We figured out what the story is about. Step 2 is we figure out the setup. And then step 3, let's write the formula, but we need to know what k is. All right, so we're going to use the example that was given. that a pitch of 440 vibrations per second has a wavelength of 2.54 feet. So we'll have the pitch is 440 is equal to a wavelength, or gives us a wavelength of 2.57 feet. Okay, we have this problem with our 2.57 down in the denominator. The opposite of dividing by 2.57 is to multiply. Those are going to cancel, but I need to do that to both sides. So we'll multiply both sides by 2.57. And that gives us what our K is worth, which is, let's see, about 1,130.8. And that is in vibrations per second times feet. It's kind of a weird unit. This is 130.8, and our formula now is P is equal to that K divided by the wavelength. All right, now we're going to use that example. Oh, no, now we're ready to solve the question. Okay, so find the wavelength when it has 2,472 vibrations each minute. Okay, remember though that our units were in seconds. So we are going to need to convert first. Convert. All right, so what we were given is a pitch of 2,472 vibrations per second, but we don't want seconds. We want to get rid of seconds, and instead we want minutes. So 1 minute is the same thing as 60 seconds. Oops, I did that backwards. Okay, it was in minutes, and we have to convert to seconds. Okay, sorry about that. So this was wrong. This was in minutes. Got to read. Okay, so it's in minutes. We don't want minutes. That's the same thing as 60 seconds. Okay, so convert to seconds first. Okay, so we're going to divide. My minutes cancel. The 60 is on the bottom, so I'm going to take my 2,472 and divide it by 60. So that's going to give us 41.2, and that is the vibrations per second. And now we're ready to plug that in to our pitch and solve for wavelength. Okay, on your mark, get set, here we go. So we want to plug in 41.2, and that's equal to 1130.8 divided by W. We want to solve for W. But W's in kind of a weird spot. It's down there in the denominator. So let's deal with that fact by multiplying both sides by W. And then we've got 41.2 W is equal to 1,130.8. And then that allows us to solve that. So we'll divide by 41.2. And that gives us our wavelength. I'm running out of room. Is equal to 27.45. And that is in feet. Good. All right, let's do this last one together. So the volume of a pyramid varies jointly. Okay, that's the story about. It's about volume. and it's varying jointly. So there's a couple different things going on, and it's varying with the height and the area. Okay, so let's give ourselves some variables. We've got V for volume, and that is in volume of cubic feet. And we also have height. And the height is in feet. And we're also talking about area. And area is in, area is square feet. Lots of feet. All right, now varying jointly, that makes me think of y equals k times x z, but our story is not about y's, x's, and z's. It's about volume and height and area. Okay. So we got our step 1, step 2 done. Step 3 is figure out the value of k. We'll use the example that was given with a height of 12 feet, has an area of 23 square feet, and a volume of 92 cubic feet. Okay, we're going to plug those in. Okay, volume of 92. Plug that in for V. Okay, is the height was 12. And the area is 23. Okay, so we have, let's see, these were feet. This was feet squared, and this is feet cubed. So my K doesn't look like it has any units because it's all the feet have canceled. Let's see, 12 times 23 is 276 times K is equal to 92. And then I can divide both sides by 276. And that gives me my K value. 92 divided by 276 is 0.333 or 1/3. You can just show that with a bar over the 3, and that's the same thing as 1/3. So my volume is equal to 1/3 the height times the area. And finally, we get to actually solve the problem in step 4. So let's see, now we want to know, find the volume with a height of 204 inches and a base of square feet. Okay, we got to make sure that we convert first. Okay, so we're given in this one, we got to convert, everything was in feet, or feet squared or feet cubed. So we want to make sure that our height of 204 inches gets converted inches into feet first. Okay, so we don't want inches. I'm going to put that on the bottom so they can cancel. And instead I want feet. So 1 foot is the same thing as 12 inches. I'm going to divide by 12 there, and that gives me a height. This was the height of 17 feet. This is a large pyramid. 17 feet tall. Now the area is 23. Oh, let's see, the height of 204 with a base of 27 square feet. Okay, so the volume is 1/3 times the height, which we just got was 17 feet, and the area is 27 feet squared. So we have feet squared times feet cubed. So our volume is going to be in cubic feet. All right, so I'm going to take 1/3 times 17 times 27. And I get 153 cubic feet.